All right, hello BC Calculus. What I'm going to do here is go over the answers for this multiple choice. Just so you know that the packets I and 2I, you do have the answer key in the very, very back. But what I want to just go over here is for select ones, I think you may have just some questions on how to do them most efficiently, and that's what I plan to hit here. I think questions number 1 and 2 are fairly straightforward. I don't quite see anything that's really out of the ordinary. Just remembering that in number 2, for example, intervals of increase and decrease. Intervals of increase and decrease are always closed, okay, or inclusive, if you will. All right. Let's see, questions number 3 and 4. This is just number 3, remembering a derivative rule, right? The derivative of secant is secant tan. Nothing too mysterious there either. Number 4, also very straightforward. The graph here goes to number 5, so don't look down there yet. Let's see, what I say would be the most common mistake for question number 4. I would say, in my experience, grading, that most people lose the 1 over x right there. They just kind of forget, just being careless, okay? Number 5, let's see. Which of the following statements is false? Again, I think fairly self-explanatory. Not a whole lot of stuff going on there. Okay, 6, I wanted to talk about particle moves along the x-axis. So we're talking about rectilinear motion. The velocity is given by this. What is the total distance traveled by the particle from time t equals 0 to t equals 3? So first of all, if this had been a calculator active question, you would just pull out your calculator and just do the definite integral from 0 to 3 of the absolute value of the velocity function, okay? That always gives you total distance traveled, okay? If you just take the definite integral from 0, the difference between the definite integral of velocity and the definite integral of the absolute value of velocity is if you do this, okay? What this gives you is the displacement. So this is displacement. This is total distance traveled. Now, sometimes the two things are indeed one and the same. So for example, if over the interval of time, your particle doesn't ever change what, everyone? Direction. Yes, if your particle doesn't change direction, then these two things are the same thing, okay? If it's calculator active, you always just would go here because that will always give you total distance traveled. This is non-calculator active, however. It's asking you for the total distance traveled. So the first thing that I just want to make sure is the fact that there is no change in direction over the interval of time from 0 to 3. And here's just velocity factored. And I'm noticing that between 0 and 3, the velocity is always positive. So it's always moving to the right, the particle. So the total distance traveled will be this integral right here, okay? And then it's just a matter of being careful, okay? Just evaluating the integral and plug and chug. Number 7, fairly straightforward, just chain rule. Yeah, I think what would be the most common mistake? I would say that this is the most common mistake, like someone does this wacky thing, which would be just so odd. Very, very odd. Okay. Here we go. This is 1. Again, nothing too wild and crazy. 8 and 9. This ties in nicely to one of your free response questions for yesterday's homework, but a right Riemann sum. Okay, right Riemann sum, just being careful that you pick the correct heights of the rectangle. They would be this, okay? Had the question asked about a left Riemann sum, they would be these y values for the heights of the rectangles, okay? Number 9, definition of continuity. We're gonna, start going into formal review for continuity and differentiability, but for continuity means that the function has to exist at 2, and it does. Okay, so the function exists at 2 because f of 2 does in fact equal k. But then that value has to equal the limit as x approaches 2 from the left and from the right. It just so happens that here, this is the expression for f, whether you approach from the left or from the right. And when you look at the limit as x approaches 2 from the left or from the right, okay, you're going to get that limit equals 5. Therefore, k has to equal 5. Okay? area of the region in the first quadrant bounded by. Okay, so the first thing that we do here is I made a very rough sketch, okay, because it's asking for the area. It's not asking for the net signed area. So if I want to find the area, I want to make sure I always give a positive number. So what I have here are just X and Y axes. I just did a little bit of mental math, just get a sense of what's going on with this function Y. I'm noticing that Y is definitely always positive, and that as X gets larger, oh, actually, this is not the most accurate graph. As X gets larger, actually Y gets larger. So see how I have like Y decreasing? Really, the function should be as X gets larger, Y gets larger. So really, it's probably something like this, perhaps. Okay, you want the area from 0 to 2. Doesn't change the math, but it's just kind of good mental habits to get into. This is the integral expression. Do a simple U sub. This is your area right here. Okay, number 11, where's number 11? Here we go. Number 11 is A. What I like about this question is, you know, this curve here, we know what y equals the square root of x minus 2 looks like, right? That would just be this portion right here. Once you do this, once you do the absolute value of it, it allows for x to be negative value. So this thing looks like a bat or a bird or a whatever. Once you get that sense graphically, it's pretty clear that A is the answer. 12, why didn't I finish 12? That's odd. Well, okay, so using the substitution u equals root x, this integral in terms of x is equal to which of these integrals in terms of u? Well, let's just do it together. The first thing I'm doing here, and again, if we were going to have multiple choice on your AP, we would talk tactics, but the first thing I'm looking at is making sure that the integral with respect to u, 9 times out of 10, people will forget that you have to change the limits, okay? So this lower limit should be root 1, this upper limit should be root 2. So as I glance any of these, sorry, root 4, which is 2, any of these that don't have the correct limits are out. So that just narrows me down to those two. Just kind of a nice tactical thing to do, okay? So I'm just going to do the u sub now. Hang on. Okay, so here's the work right there. Whoops, what am I doing? So here's the work right here, and the answer is C for number 12. Here's number 13. Nothing too crazy, number 13. You gotta just break up that integral, right? Because this is f of x is defined differently depending on whether you're greater than or equal to 3 or less than 3. So if you want the definite integral from 1 to 5, you've got to do this first. You've got to break up the integral. Okay, and then it's just a matter of just being careful. Okay, just being careful. Boink, boink, boink. Yep. All right. And then here, okay, if f of x is equal to this and g of x is equal to this, then the derivative of f of g is what? Just straight up derivative. And you'll notice here I messed up somewhere, but let's just see if I can find it. F of g is the square root of, right? This is f composed of g. So g is put into f, so to speak. So f of g is the square root of x squared minus 4, but the x is now g, right? Very good. So the derivative of this is going to be 1/2 times the entire radicand raised to the negative 1/2 times the derivative of the inner, right? Okay, and then at x equals 3, the derivative is going to equal 1/2 times, I'm getting 7 squared minus 4 to the negative 1/2 times 2 times 7 times 3, right? So this doesn't equal 1/2 times 1 over the root of 45 times 3 times 14 times 3. Oh, there it is. Yeah, 42. Okay, so this should be 42 over root 45 or 21 over root 45. Guarantee the answer is going to require simplification of the radicand, sorry. This just equals 7 over root 5. And let's see, where's that? A, there it is. All right, folks. Okay. I'm going to post homework for Monday. Oh, no, wait. Is Monday drop? Let me see quickly. Okay, Monday's drop. I'll post homework for Tuesday soon, just to get ahead of it. Homework / classwork. And then guess what? When we Zoom live on Wednesday of next week, Wednesday of next week, bear in mind, Wednesday of next week, we Zoom at 9:10. Okay, 9:10. I will have all the AP information. And we're gonna just knock it out of the ballpark, everyone. All right, folks, have a great weekend. Do well, be kind. All right, goodbye.